Alright, we're going to go ahead and start into our second video. So this is going to be 9.2. We're actually going to focus on the relationship between mass and the mole. Now, I'm not sure if I made a lot of or made a comment about this in the first video. And so one of the big things that this is going to help us to be able to do is, as we look at how mass is related, or the mass of a compound is related to the number of moles and so forth, it's going to help us to be able to move from what we call a microscopic to a macroscopic view. What do I mean? I can't handle an individual molecule. It's very difficult because it's very tiny. Even with the smallest amount that I could think of, I would still have more than that. Now, I need still some way to be able to carry out the reactions and to be able to actually accurately carry out my understanding of how much of the product is going to be made and so forth. So the way that I do that is using or converting between moles. Now, as we start into our second video, this is what we're actually going to spend most of our time talking about. The goal is by the end that you'll be able to calculate molar mass of a given compound. That one's straightforward. But then also use that molar mass or that understanding of a molar mass in order to convert between grams and moles. So the first video was how many. Now we're looking at how much. Again, first video, how many. Now we're looking at how much. Go ahead and rank yourself. Where are you on this scale? Where do you fall? Are you at a 1, 2, 3? Or maybe you actually already know this a little bit, and so you're skyrocketing. You're already on level 4. We're going to go ahead and test that in just a moment. Now, let's move in. What is molar mass? Simply the mass of 1 mole in grams. Now, the basic idea that we use here is we've calculated, or when we look at the periodic table, most times we get what's called the average atomic mass. Great, wonderful. That mass is given in a very, very small unit that we used before. It's called AMUs, or atomic mass units. That doesn't help me when it comes to doing a reaction. It's a little too small for me to handle. So what I'm going to do instead is I need something that I can use in grams, something that I can measure out and it makes sense to me. So we get this thing called molar mass. Now, what this is telling me is if I have 1 mole of carbon atoms, it's equal to the average atomic mass, which I get from the periodic table. So 1 mole of carbon atoms is equal to, which I look at my periodic table, it says 12.01 grams. 1 mole of magnesium atoms, 24.31 grams, and so forth. Copper atoms, 1 mole, 63.55. The same idea, so we can use those same values. Now we're just going to change the unit. Now, these are a couple of names that you're going to hear thrown around, and I need you to understand that it's going to be the same number, but the unit's going to change. If you hear molecular mass or molecular weight or formula mass or formula weight, each of these times we're looking at the combined mass of all of the atoms that are involved in that molecule or in that formula unit. But instead of looking at it in atomic mass units like we talked about before, we're going to look at it in grams. And this is what we say is the beauty of Avogadro's number. Because of the fact that we're taking into account this this ability, or this number of atoms involved, now we can deal with things on a scale that makes sense to us at our current state. Now, let's do a quick check. Now, if we're looking at the molar mass of each of these different things, 1 mass of bromine atoms, take a moment, look at your periodic table. What's the mass of bromine? Okay, for the second part, what's the mass of tin? Now, do you need me to go through it? Not really. Why? Because if you're looking at your periodic table, you'll look and you'll find bromine, boom, and the mass is right there for you. Same thing for tin. Notice symbol for tin, SN, not T, so don't look for that. Now, how are we going to use this information? This is where it becomes a little bit important. This is just a way for you to check and see, did you actually get it? Now, we're going to use this information in just a second to actually convert between grams and moles. If we have a compound, in the case of what we have here, now I realize I'm jumping ahead of myself, I have 1 mole of calcium chloride. Has a total mass of, well, let's look at it, 111.1. Well, how do we get this value? Well, we know that calcium has a mass of 40.1, and we have 2 moles of chlorine. How do I know it's 2 moles? Well, take a look at the formula right here. That nice little subscript 2 tells me I have 2 chlorines involved. So that means I have to have 2 times the mass of chlorine. So 40.08 or 40.1 plus 2 of my chlorines, which each have a mass of 35.5. Then I'm going to add all of that up and come out with approximately 111.1. Now, notice the unit that is given here is given as grams per mole. So 1 mole of calcium chloride has a mass of 111.1 grams. This is going to be your basic unit that you use for molar mass. If we're trying to find the molar mass, this is what you're going to use. Now, here's your learning check. Here's the opportunity for you to write on your own what the actual value is. Question is, how many potassium do you have? How many oxygen? How will you then put that together to actually get your values out? Take a few moments. You're going to look at this and we'll come back to it in just a second. All right. Now, this was another example that you can use, but we'll deal with that one in class. Now, when I want to do my conversions between grams and moles and grams, the biggest thing that is going to be my bridge between the two is going to be my molar mass. Because I know how many grams are in each mole, I can then use that to convert between the two. So, use an example of what we have here. Aluminum is often used as a structure in lightweight bicycle frames. How many grams of aluminum are in 3 moles of aluminum? Well, I need to go from 3 moles to grams. And as we said before, it has one of 2 ways that it can go. We can go 1 mole, equals molar mass. So, how will we set up our conversion factor? Well, let's set up our table first, actually. So, 3 moles. And where do we go from here? Well, if I have moles here, that means moles at the bottom. And grams is going to be at the top. Let's take a look at the next slide and see how we actually set it up. Now, one of the keys here is we need to set up what we actually know. Well, the molar mass of aluminum is 26.98 grams. We found that. So, we have 2 conversion factors that we can work from. We can either go with the molar mass over 1 mole or 1 mole over the molar mass. In our previous slide, we already set up and said that 1 mole needs to go to the bottom. So, this is going to be our conversion factor that we're going to use here. Now, plugging it into our table, our given goes here in the top left with our molar mass at the top, 1 mole at the bottom. Take a moment if you have a calculator or one in your cell phone, whatever, and I want you to actually calculate this and see if you come out with the same answer. My final answer was 81.94 grams. Did you come out with the same response? If not, you want to check and see how did you plug in the information and what can we do to try to fix that. Now, this is another check for you. I want you to go through and actually calculate how many moles of aspartame are present in 225 grams of aspartame. It's given to you as the formula, C14H18N2O5. So, of course, that means you're going to have to find the molar mass of that. It'll take a few moments, but I think you can work through it. Now, use that one as a practice, and I'll go back just a second. Take a moment, if you got to screenshot it, you got to pause it, whatever. I want you to come to class with this one answered. If you can come to class with this one answered, I'll know that you have a basic idea of where we're going to start and what we're going to do with this information. Take your time, rewind, review anything that you still are not understanding, and bring your questions with you to class. Have a good afternoon. Oh, before we go, make sure to rank yourself on the scale. Where do you fall? Have you improved from where you were to getting the basic idea, or do we need to go a little bit further? Did you skyrocket from, say, level 2 all of a sudden up to level 4? You see the ways that you can use this outside of this class. Let me know in class. I'll see you tomorrow, and have a great day.